Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm Arif and I welcome you all in today's session. Well, to access the notebook for today's session, you can access course page on my personal website arif.me. You can click the appropriate link under the lecture resource column to view it in Jupyter NB Viewer and can run it online in Binder. Well, the other way is to download it from the course GitHub account RFPUCIT, and here is the public data science repository. Well, this is the Jupyter Notebook dashboard running locally on my machine at port 8888, and here is the notebook for lecture 2.15, rather part 1 of lecture 2.15 of the second module, basic Python programming, for the course titled Tools and Techniques for Data Science. My dear students, I have divided this session in two parts. In part 1, we will create and use our own Python modules, and in part 2, we will create and use our own Python packages. But before we start with this part, let me acquaint you with some related terms. Okay, the first term is Python script. My dear students, we have been writing our Python programs in Jupyter Notebook file with extension IPYNB. However, in the initial sessions, we do have written Python programs or scripts in simple text file with this .py extension. So this is a script. Remember, a script is a file having Python code written outside the scope of any function or class. As you can see over here, this piece of code, these 3 lines of code are not written inside the scope of a function or a class. So when we are going to run this Python script, it will do something. I think now you will be able to understand the Python module, the second term. A Python module is also a file with .py extension. It often defines functions, variables, and classes, and this code inside it is not normally intended to run directly. We normally import Python modules into Python scripts or maybe in other Python modules. The third term is Python package. My dear students, in our computer systems, we store our files in well-organized hierarchies in different directories and subdirectories instead of storing them in a single directory. Similarly, when our software applications grow, we divide them into packages. Well, a Python package is basically a directory having one or more Python modules. So this is a package having one module, this is a package, and this is another package having 2 sub-packages. The point to be noted over here is that every package directory has an additional file with the name __init__.py over here as well, and in this package directory and in this package directory as well. And this init.py file can be empty or may contain some initialization code. Well, of course, this is the sample project for the package creation that we will practically do in part 2 of today's session. So I will describe it in more detail over there. Let's move ahead and talk about the fourth term. The fourth term is Python library. That can have tens or even hundreds of individual modules providing a wide range of functionality. My dear students, the Python standard library comes bundled with the Python installation, and you just have to import appropriate modules like math, random, datetime, OS, sys, and so on to use their functionality, as we have done in the previous session. In standard Python library, we do have built-in constants like true, false, and none. We do have built-in numeric types like int, float, and complex, sequence types like list, tuple, range, and string, set types like set and frozen sets, mapping types like dictionary, and built-in functions like print, max, min, input, help, sorted, iter, next, and so on. And we all have seen these things. Other than Python standard library, there are tons of other libraries like NumPy, Pandas, Matplotlib, and so on that you normally have to download and install using either pip or conda, which we inshallah will be doing in our third part. Anyway, finally, the fifth and the final term is Python frameworks. My dear students, Python frameworks make the life of developers easy, as they don't have to worry about the low-level details such as protocols, sockets, or thread management. And some famous Python frameworks are TensorFlow, uh, Flask, and Django. Okay, enough of theoretical knowledge. Let's move on to the agenda of today's session. In the first part, we will create and use a module of our own. We will use how we will see how Python interpreter locates a module, and how we can reload a module in our script if it has been modified. In the part 2, of course, we will talk about the packages, and we will create the packages and use them. Okay, so first, let us create a module having something like this. So let me create a module, mymodule.py. This is the title. I just want to have two variables in it: author containing Arif, but badge containing 2021, and three functions: my factorial, my index, and my sort. To save time, I have already created this file named mymodule.py, and I have opened it in Jupyter Notebook. So this is the file. If you see this factorial function, it is passed an integer, and it computes and returns the factorial of this number. Okay. Similarly, over here, this function is my index. It is passed a list of numbers and a number to be searched from that list. If the number is found, the function returns its index. Otherwise, it returns -1. Okay, so finally, this is the third function, mysort. This mysort function is passed a list of numbers, and it uses the selection sort algorithm to sort the element of the list. This second argument in place to this function is optional, having a default value of false. So if no argument is passed, that means in place is false. So we will move on to the control will move on to the else path. Over here, you can observe that we create a copy of the list of numbers that is passed, and then sort the copy of that list and returns that copy. So actually, this numbers list that is passed as reference to this function is not sorted and modified, and it remains as such. On the contrary, if this function is passed with the in place argument set to true, the control will move on to this path. And over here, you can observe that it actually sorts the numbers list that is passed as reference and returns none. I hope this makes sense. And let's fall back to our notebook file and use this module. Okay. Fine. First of all, let me restart the kernel. Okay. Fine. So this module is there in the present working directory. Let me import it and make an alias of it as mm and check out all the symbols in this module, and you see my factorial, my index, my sort, these symbols are there in this module. And the value of author is Arif Bhatt, and if I check out what is this symbol, and this symbol is actually the name of the module. My dear students, there are certain other symbols that come up when you call dir, and one of the important is name, underscore underscore name underscore underscore, which contains the name of the current module. And this variable underscore underscore cached underscore underscore, this also requires a bit of attention of yours. You see, once I execute this cell, it has output mail something like this, and this is the file that I just want to talk about. My dear students, this uh, uh, PYC files are created by the Python interpreter when a .py file is imported. So over here we have imported my module.py, and Python has created this .pyc file corresponding to this module. This .pyc file actually contains the compiled bytecode of the imported module, so that the translation from source to bytecode can be skipped on subsequent imports to speed up the startup. This is automatically generated, so you don't have to worry about it. If I come up to the notebook dashboard and inside the module files, and over here this file is not visible, maybe in the over here this is not visible, but if you look into it to your file manager using the operating system, you will find this file over there. Okay, and similarly this is the built-ins underscore underscore built-ins that contains a dictionary of key value pairs, all the symbols that comes up by default once you run the Python environment. You see the len, the iter, the input, all the built-in functions that we have used so far are here. Anyway, okay, fine. So let's use the factorial function first. So remember, I have imported the my module with the alias of and I'm calling the my factorial function with the value of 5. So it is giving me 120, which is right. Let me call the myIndex function, and we all know that myIndex function is passed a list and a value of that list, and it returns the index 0, 1, 2, 3. So this will return 3. So this is working again fine. We can use the sort function. My sort function is pass the list, and the second argument is not passed, so that means in place is false. So this will sort this list. This list will be sorted. I think that this is not the case. So if we say in place is not passed, in place is false. So once in place is false, a copy of that file is created. A copy of that file is created and nothing happens to the original list. So a copy of the file is created, it is returned, it is sorted list, and nothing happens to the actual list. Okay. And on the contrary, if we pass in place is equal to true, so when we pass in place is equal to true, so this will be executed, this portion of code will be executed, the actual list will be sorted, and it will return none. Let's check this out. So it will return none, and let me check out the list this time, and the list this time is sorted. Great. Okay, so next point is, my dear students, how Python is going to locate a module. In the above scenario over here, this module was in the same directory in which our IPython notebook file was. This creating underscore module ipynb was the file in which we were using this this my module.py. So both of these are in the same directory, no issue. Uh, Now we need to check out how Python locates a module. Let us try to import a module named Arif module that is located in this path, and and that is of course not there in the current working directory. Let me run it. So it has raised an error. It says no module named Arif module is found. So let's track it down and see how Python interpreter locates a module for us. First, my dear students, first of all, Python interpreter will look for the module in the current working directory. That is the directory from which the input script was run. So let's use the list dir function of the OS module to list the contents of the present working directory. You see over here, Arif module is not there. We have this creating module.ipynb, which is this file, and we don't have Arif module over here. Okay. So if the Python interpreter cannot find that module in the current working directory, it then search for that module in the list of the built-in modules of the Python standard library. Let's see the list of the built-in modules. So this is the list of the built-in modules, and of course Arif module is not over here as well. Fine. Finally, if there is no built-in module of that name, Python looks into a list of directories that is there in the path environment variable, sys.path environment variable. Let me check the value of this variable. This contains the path of these directories, and these are the directories. None of these directories contain that directory which actually contains Arif module, and hence that was the error. That is the module not found. So one way is that you just copy that module into the present working directory, or you may like to change the environment variable path, sys.path, and you can do that using sys.path.append method, and you pass simply the absolute path name of that location where that Arif module is. Let me tell you that this Arif module is there inside over here. So I just note down the path and I mention the path over here. I execute it. Now this sys.path do have the path of this, and once I will try to execute Arif module, it will be a success. It will be a success because it has just executed whatever was written in that file. Let me show you that as well. So this was the module. It was just having a single print statement saying something like this. This was just for teaching purpose, my dear students. Okay, so we now clearly understand how Python interpreter search for our module. So first look for the module in the current working directory. If not found, then it look for the module in the list of the built-in modules of Python standard library. If not found, then it will look for the module in all the directories whose path is given inside the sys.path variable. And if not found, it raise an error, and you can always append the path of your choice to the path variable. Okay. Finally, the last concept, that is reloading of a module. My dear students, Python interpreter imports a module only once during a session, and this makes things more efficient. By that I mean, if I have written import this module, and then after some time I again import this module, module is not imported twice, it is imported just once. And to prove this, I just have a module named demo module over here. Let me show you that demo module, this demo module, and this is just for teaching purposes. This has a print statement. This is the demo module, only one print statement, and so on. Okay, so right now, since this is not loaded in the current environment, so once I will execute this cell, so the code inside that module gets executed. And now if I execute it again, that is I try to import that module again, you see, let me do it again. The code inside that module is not reloaded. So this is what I just want to say. But let's consider a situation that you have made modification in that module. This is the module and I have made some modifications and I have said, okay, this is it. And I have saved it. Let me fall back over here and let me run it again. So it is not executed, although I want it to be executed. So we have two options. One, I restart the interpreter. I just stop it and I just say the kernel to start it again, or I use the reload function of the imp module. I can do this as well. Let me do this. And you see, the module is again loaded. And if I do it again, let's suppose that I say import demo module, so it will not give us anything. Okay, so this dir function, you all know about it, there's no issue of it. So we are done with the first part, my dear students. That is, we have created and used a Python module of our own. Let me move on to the second part of today's session now. And for that I have this file, my package demo. So today in this part we will see how to create and use a package of our own. So what are packages? Once again, as already said, a package is basically a directory having one or more Python modules. So this is a package, this is a package, and these two packages are again bundled inside this package. And the point to remember is that every package must have a file named __init__dot.py, which can be empty or may contain some initialization code. And being beginners, I will have an empty __init__dot.py file. Okay, so let me come up over here. We have this package demo. This is my package.ipynb in which I was working right now. This was my package demo having package 1, having arithmetic.py. Let me click this. Well, this arithmetic.py contains some basic functions: my add, my sub, my mul, my div, and my power. Okay, so this is the module, arithmetic module. Just one module in this. Let me come up to package 2. In package 2 I have two modules, the bit compare. The bit compare is doing the bitwise AND, bitwise OR, bitwise NOT, and so on. Just simple piece of code. And this is the comparison module, and this comparison module is just doing a bit of comparison. My dear students, I've just created these just to make you understand the use of packages. So let me fall back over here. So this is the text what I have written. Remember, you need to create a hierarchy. Over here we have the hierarchy. We have the package demo at the top, and inside the package demo we have two packages, package 1 and package 2. And inside package 1 we have just one module, arithmetic.py, and in package 2 we have two modules, comparison.py and bitcompare.py. And remember, every directory within this hierarchy must have this initialization file in it. And I have shown it over here as well. So this is the package 1 arithmetic.py file. This is the module. This is the bit compare module inside package 2. And this is the comparison module inside package 2 again. So package 2 has two modules, comparison and bit compare. Okay. So we are done with creating a package. Now I need to import it and use the modules from that package. Let's see how we can do this. and use the function inside the, let's suppose first let's use the function inside the arithmetic module. I just say import package demo dot, inside that I want to use package one, fine, and inside that I want to use arithmetic. Okay, fine. So I want to import this, fine, and let me do this. I have imported this. Let me use it. Package demo, inside package demo, package one, inside package one, arithmetic, and inside arithmetic, I want to use, let's suppose, my mul, and I know I can pass it two arguments, 12 and 15, and let me run it. It is 180. Great. However, there is a lot of typing that is involved. So let me use the concept of aliasing. Let me just copy this from here, paste it over here, and say import this as, let's suppose, ABC, and do like this. And over here now it's very simple. I will just say ABC dot, and let's suppose my power 2 comma 10, and there you go. Great. My dear students, similarly, if a package has a lot of modules, you can import a specific module using the from keyword as well. From package demo dot package one, let me import arithmetic. I have imported it, and now I can simply say arithmetic dot my add 5 comma 3, and there you go, you have the answer. So this will also avoid that long construct while calling the function. Great. Well, another way of importing is that you can import all the functions of module using the static operator. So let me do that as well. From package demo dot package one dot arithmetic, I want to import everything. So I've imported everything, and now I can simply say my add 3 comma 9. So it will work. Note that this let you access your function directly without using the dot notation. Let me use the dir function over here. But dear students, remember that once you import everything from a module, you get everything, all the symbols over here, my div, my mul, my power, my sub, and so on. And do keep this thing in mind that if there are a lot of functions in the module and you do such imports with a lot of modules, it may cause namespace conflicts. Similarly, my dear friends, you can import the comparison as well as the bit compare modules from this package and use them. And over here I have just imported all of them as with different aliases. I hope you will be able to do that at your own. So that is it, I think. Yes. So that is all for today's session, my dear students. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning, and Allah Hafiz.